Okay, we will start this chapter number 4 of the estimation of the unit root, right? A continuation from the part 1 of talking about the unit root, the understanding of unit root, the understanding of having the characteristic of unit root and understanding the individual characteristics. So right now we are on the EViews again, back to EViews again, because this part will be very important, especially to ensure that every one of you understand the concept behind EViews, especially for unit root. Let me get through these slides and then I'll show you, especially on EViews itself, because that's the most important part. It's going to be this one going to be a while, especially. All right, we're talking about this one. Okay. All right, let me try this thing off. Okay, let me put this small. All right. Yes, the practice. So let's estimate unit root. At first, certainly you need to have your data inside the EView software. Surely, from Excel, can do that again. We copy and paste again back at that. Right. In this example, we will only use. In this example, we only will use a variable LGDP in this sense. Yeah, this LGDP, so that just to prove the point what is going on here. Okay, so first, and the ADF test, right? First, we will use the LGDP for the example. Okay, double click on the variable that you want, especially LGDP in this sense, and then this thing will pop up, and then we will see what is going on with this example. Okay, then I'm going to test it. Level first different too. Level first different with intercept and trend. I will also mention this back to the chapter number 4 later on. The part 1 here. This is the continue on and continue on. Let me go ahead with the proper EViews program here. Okay, let me open up this thing first. Right, this is for University Sarawak actually. Our data is based on this one. I will need to open this thing back, and also this one. Okay, there are a few files that I need to mention to you surely. Okay, we will start off with the copy and paste first. Let us copy and paste all these 6 column of data into EViews first. Okay, you create a new file, annual 1975 2008. Okay, and go to say no here first. Go to quick empty group, where you put your cursor here and then you paste. Right, that's how we go. Yeah, voila, this thing. You need to save this work file so that you don't have to do it all the while. So we're going to just focus on this one variable LGDP, which is the log of GDP here. All right, the log of GDP. Okay, this open up this thing as per the slides here. Yes, and then we straight away go the estimation. Here estimation here, we have unit root here. If you go view here, you see unit root test here. Alright, nothing to be. Let me try to make this thing bigger. Can I? Yeah, that's the use of that later. So go to view, go to unit root test, and you have straight away the first unit root 1, 2, 3, 4, 5, 6. As been mentioned in part 1, you have 6 different types of unit root here in EV 1, 2, 3, 4, 5, 6, 6. 6 type. We're going to focus especially on few that's available, but you can try the rest. I'm going to focus on ADF, and I can try KPSS and this DF-GLS, the second one here of Philip Perron or something like that. Right? Alright, this is ADF. So what you need to do, you need to test for level first. What is level? Here if we go back to these slides, where is these slides? Yeah, we go back to these slides. If you still remember, when you go back to these slides, this part, yeah, especially on this part here, this 1, 2, 3 equation, this equation is actually without the trend and intercept. This is with the intercept, and this one is trend and intercept. Where is it? Where the heck is that? This one is here. Intercept, trend, intercept, and none. So it's none. The first one is none. The second one is with intercept. The third one is trend, intercept. So we have to do few times here, level first different, and then intercept, and then trend and intercept. So and you can put it nicely in the table, right? You can put it nicely in the table like this later, right? You can put in nice table, yeah, as such, you know. The table of unit root will be like this, yeah, for example. Okay, this is already the result that I already put in, and my table have consists 3 different estimation method, which is ADF, DF-GLS, and KPSS. I'll give you this table, not now, not right now, not today, not when this chapter 4 is being viewed. Right, so what you need to do, you just have to click here as per the slides. Again, we go back to the slides here, yeah, here. Click level intercept and then click OK. This is the result. Basically, if you just click OK, let it be automatic for the lag length. What is lag length? Is the amount of lag, means that the whether it's t-1, t-2, t-3, or so on and so on and so on. It depends on the data itself. Right, click OK. This is the result. This is the result that you need to interpret the t-statistic and the probability. The t-statistic you can compare with this, or you just refer to the probability straight away. The rest of the result, not to say not important, but the rest of the result not to be reported. Normally we reported this thing. And to show you what is happening down here, actually, if you see here, what is happening down here, based on the slides. Let's go back to the slide here. You see the slide here, this one. Go to the second one, this equation here. The difference of yt, and then you have alpha 0, and then yt minus 1, and so on. This variable. If you look back at this EView, actually, this one actually refers, this whole equation actually refers to this slide here. This is the part here. Okay, this is the part here, which is here. Actually, this is how we do how EViews do the estimation, and you refer this one, this t-statistic, as actually this t-statistic. It's just that the probability used is not the same as the t-statistic probability. We use the test critical value of the augmented Dickey Fuller, which is different. Alright, so how to interpret this? If you put this thing in the table nicely like this, as still per my result here, if you see lag 1, what is the lag? Right, yes, lag 1, automatic, and this is the t-statistic, the probability. You can report this thing, and the lag 1 and the critical value. The result shows that actually, with this, this is the first time. The result shows that it's actually do not reject. Follow at what your understanding in your previous class. Right, especially how to interpret the probability. If we use 5%, it's not rejected. 10% also not rejected. 1% surely not rejected. So not even rejected at 10%. What's the null hypothesis here? You see that, read the null there. The null says that LGDP has a unit root. Has a unit root, right? Has a unit root means or meant non-stationary. Random walk. Yeah, these two. Alright, so if you reject, means that the data is stationary, but here you do not reject it. Yeah, we do not reject, so that's why you have to move to first different. If you still remember these steps, the next one, where is the steps? Go back here. Right, if you still remember here the steps. Okay, where's the steps? Let me find the slides. Okay. somewhere here that we do the steps here. This one, right? Test the variable to see if it's stationary. If yes, then we conclude I0. If no, we continue on. So now it's not stationary yet. So we continue on with first different. Okay, that's based on these slides here, right? Based on these slides here, we can see here. Continue on with trend and intercept. We try to test the two models first. Go back to view, go back to unit root test, go back to trend and intercept, and click OK again. See the result here, right? 3.355 at 1, right? 3.355 at 1. Right here, different lag. If it's automatically selected by EViews, it says 1. Here you see that is 0.07. If you use 10% as your benchmark for significance, then it's rejected. If it's used 5%, it's not rejected. So the decision to be made. This is an interesting observation, right? So both here. So it doesn't matter here because that's the command, but just put there so that you understand the thing. We have tested for unit root level LGDP where intercept do not reject. For trend and intercept also do not reject at 5%. Alright, so that's the conclusion. So now we move to first differences. Alright, so we move forward to first differences. Say go back here to unit root. Go to the first difference. You can start with the intercept first, or either way, right? Move forward. That you see here right now, the null hypothesis D is different. The notation D is different. If you have different 2 times, it'll be 2. I will show it to you later on. So LGDP has a unit root. Here is 4.595 with a lag 0. No problem, because that is automatically selected by EViews. I would love that it would be good that EViews selected automatically for you rather than you determine your own lag. That'll be better. At least you can write it out better, right? Okay. So 4.595. That's the result here. We put back here. You see here 4.595. So here at first difference. At the first difference, we reject the null. Means that the LGDP is stationary. Is stationary. No unit root and mean reverting. These are the terms being used. Stationary is to use for non-stationary. No unit root is for unit root, and mean reverting is for random walk. Random walk, the walk that is random. The mean reverting means that it fluctuates around the mean. So here now it's fluctuate around the mean at first difference. Okay, so as we follow these steps, we shall stop there. Right, it's stationary, then we stop. Okay, all right, okay, all right. Here just now we do estimate this model and this model. We do not estimate this first model, but if you I want to show it to you, can show it to you. But then again, we go first different first. Here, yeah, we have the same conclusion. Here is also rejected, right? Also rejected as per my table here. Or if I go back here to unit root again, right? Go to back to unit root again. I go this model, none level. This is the one without the constant. You see, there's no constant here inside this estimation down here. Where else this one If I use either of the model, you have constant here. If I use the trend intercept, you have the trend. All right. So that's the difference between the three different models, which is available here in these slides, number 17, in this chapter number 4, and these steps, right? So 16 and 17 here is important in that sense. So we click OK and so on. We summarize it down, and we repeat the estimation process for the rest of the variables. So let's say you have 4 variables that you need to repeat all these things. So one variable you need to estimate 1, 2, 3, 4 times. Say 3 variables you need to complete this for one test. And then we move forward to another test and another test KPSS. Alright, this is what normally we've been doing. Why we need to do at least 2? So that to be consistent and robust, rather than just reporting one result. One single result, right? For robustness. For robustness, for robustness, robust. Robust means that trustable result. We need to test more than one method of unit root. All right. So ADF maybe. ADF, normally you'll report ADF, KPSS, and DF-GLS, or PP. It's up to you. Your choice is there. You have 6 choices there. You can choose 2 or 3 just to prove the point there. Okay. Well, you can always try that thing off. Right, try DF-GLS and KPSS too. Right, this is certainly available in EViews. This is DF-GLS. DF-GLS is the same understanding with ADF. Let me show you DF-GLS. Alright, this is DF-GLS. You click on DF-GLS, you see the same setting, except that there's no option for none. Let me go this thing. See here, 0.396 with lag 1. You can always report it here. Just put straight away in the table, rather than you print out and so on. And you reported this thing nicely. Put it there. So here has a unit root, do not reject. Same thing, same conclusion. With first different hit is rejected because it's larger than this value. There's no p-value given. It's okay, no problem. That's how is it. Yeah, so rejected, and this is the DF-GLS. Right, this is the DF, this for example DF-GLS, right? So this is for DF-GLS types. They can involve the KPSS is more interesting. Go ahead and see KPSS. I'll show to you what is KPSS here. Right, the KPSS here, see, is different setting, a little bit different. It changes accordingly. Go for level, go for intercept. If you see here now, the null hypothesis here for KPSS. Right, for KPSS, the null is stationary, different from the rest. This is more interesting to check the robustness, especially when you have a different types of different null hypothesis. So you want to check. So here in understanding is that here if you see right here now is rejected at 5%, but not at 1%, at 5%. This is larger than this one, right? Figure. So is rejected at level means that is not stationary. Okay, so when we do the first difference, here for KPSS, and then you'll see what happens. You do the first difference, you see that now the value becomes smaller. Because smaller means that do not reject. Do not reject means that it's stationary. After first difference FD, it becomes stationary. And we stop there. Right? As per the suggestion, and we stop there. So that's why how we report all these 3 methodology inside one table. Okay? Yeah. Alright. It was a lot, especially if you have 3 variables here and then the 3 types of unit root. You have 36 estimation. How many times do I have to click? So the idea is happy clicking, my friends and all of you. Right, so you can try this thing because this is a video, so you can always pause if I talk too fast rather than doing live, but I will show it to you also. If you have some issues, especially on the estimation, I'll show it to you in the class. But watch this video carefully, especially this video mounted nearly 20 minutes. Any comments, certainly on the video, I'll give you this table accordingly when times come, because to fill up this thing. This is my result full from chapter 4, 5, 6, 7, 8. Right, so this is what basically that we're going that we have discussed here, the unit root test to test the 3 variables of LGDP, revenue, and expenditure. Okay, and using EViews. So for time being, I think I shall stop here. Thank you very much, and I'll see all of you again in the next video. Adios.